Hello everyone. Good morning, good afternoon, and good evening for all of you. My name is Aditya Tirta Kusuma from Institut Teknologi Bandung. Today I would like to present our research in entitled Geochemistry and Economic Viability of Rare Earth Element at Tanjung Pandan Offshore, Belitung Island in recent sediment for placer deposit exploration. First, I would like to introduce the author of this research, me, Aditya Tirta Kusuma, and then Bari Majeed Hartono, Ahmad Najili, and Mr. Bambang Priadi from Institut Teknologi Bandung, and also Mr. Maman Surachman from Pusat Penelitian Pengembangan Geologi Kelautan. First, we begin with introduction. Recently, the demand of REE in high technology industry enhanced the RE exploration to focus on the area in which the granite are occurred, since the granite are the main source of REE. The REE are commercially occurred in secondary deposit such as lateritic deposit and placer deposit in Indonesia that were primarily derived from granitic rock. In this paper, our study focused on the RE placer type deposit. Study in RE placer type deposit could be an interesting subject due to it's not about the exploration, but it could also improve our understanding in marine geology. Belitung Island is suitable for such study due to it has been well known that the island, together with Bangka, are the main producer of tin commodities that also associated with REE in form of placer deposit that are derived from granitic rocks. Most of research are focused on granite rock and placer deposits. However, geochemical studies of REE in unconsolidated sediment in Belitung Island are rarely done. This paper aims to determine the RE geochemistry in Belitung offshore. Our study also observed the lateral distribution of RE in recent sediment. These RE behavior studies could improve our knowledge of the geological process in the marine system, such as erosion and also sedimentation. And then this paper also aims to determine the RE economic viability of recent sediment in Belitung offshore that could give suggestion for the next RE exploration target interval. For next is about the geological background from the research area. So Belitung Island is chosen as our research area due to its huge tin placer deposit that are derived from granitic rocks. One must remember that placer type deposit is commonly associated with S-type granitoids, since the observed RE-bearing mineral in S-type granitoid are xenotime, monazite, and zircon that resistant to erosional process. Therefore, the occurrence of S-type granitoid in Belitung Island is crucial that directly controlled by Sumatra tectonic history. Based on potassium argon dating, suggests that Tanjung Pandan granitoid are a product of episode D1 magmatism that related with collision between the Sibu Masu block and Indochina in late Permian until early Triassic. Our research area is located in Northwest Belitung Island. The data are provided by Pusat Penelitian dan Pengembangan Geologi Kelautan from their annual survey in 2013. There are 28 unconsolidated sediment samples taken from Belitung Island that show in green dot in here, and then consists of 16 deep marine sediment sample, several coastal sediment sample, and 5 rock sample from the terrestrial unit. The sample then were analyzed for its REE and trace element content by ICP-MS method that was done in Pusat Sumber Daya Geologi Laboratory Bandung. Now we come to the result and discussion from this research. First is statistical correlation. So from this statistical correlation, is carried out between REE, trace element, and also major element. The result is shown in table 3. There are several points from the correlation, which are there are strong positive correlation between each REE, shown in green color here, indicates that REE will always occur together. And then high positive correlation with, between zirconium and REE indicates that REE associated with zircon mineral. And then there are positive correlation between yttrium with REE, means that REE possibly associated with xenotime. And then there is weak correlation between phosphor with REE. It means that there is a little occurrence of monazite mineral. And then there is no correlation with Al and silicon with REE. It means that no RE associated with clay minerals. And then for the last, there is a negative correlation between carbon and REE that indicates REE are not associated with bastnasite. Next is source of the sediment. There are three possibilities of rock that act as source of Belitung sediment based on the geological map in Figure 1, which are Cretaceous Burung Mandi granite, so in red color here, and then Jurassic Tanjung Pandan granite, show in pink color here, and then upper metamorphic basement, show in brown color here. Therefore, the sediment geochemical dataset is plotted in spider diagram with the normalization from Tanjung Pandan granite, Burung Mandi granite, and then upper continental crust. Based on the spider diagram, it could be inferred that our sediment, both coastal and deep marine sediment, have typical characteristic of upper continental crust, since the UCC normalized spider diagram shows similar pattern and also show the value close to 1. The pattern of sediment sample, which normalized with Tanjung Pandan granite and Burung Mandi granite, shows a pattern below 1, suggesting that the sediment on the coast of Belitung are not derived from both granite. So, according to the normalization above, the sediment are derived from low-degree metamorphic rock. It also supported by the low concentration in silica, and also dominantly distributed in the research in Belitung Island. Consequently, the sediment in the research area are not enriched with the REE and are preferable to be extracted. And then I would like to explain about trace element and RE distribution. So the distribution of the RE, such as lanthanum, cerium, and other, together with the trace element such as niobium, tantalum, and zircon, are represented by ISO concentration map in Figure 4. So the ISO concentration map of REE show a relative similar pattern between each other, and also with niobium, tantalum, and also zircon. Element concentration values tend to be higher in southeast part of research area, which are the terrestrial unit. However, the ISO concentration map of gadolinium and samarium show a contrast pattern with the other. With the other is showing low concentration in southeast part of the research area. It happens due to the terrestrial unit sample are not analyzed for their content. Therefore, it could be concluded that RE concentration tend to be higher on the terrestrial unit. Some elements also show fairly high concentration in northwest direction, which is the marine. For the example is lanthanum. This may be caused by terrestrial placid sediment which being transported and deposited in the deep marine. For next is about economic viability from research area. As shown in Figure 5, the high REE trace element concentration in deep marine setting is situated in BLT5 location, and then in coastal sediment sample, high REE, tantalum, and niobium content is found in BT1 sample. In terrestrial sediment sample, REE with high concentration is found in LP12 sample here. From the pie chart in Figure 6, The sediment in Belitung offshore, which are represented by sample in our research area, are enriched with cerium. This could give significant effect on metallurgical industry in Indonesia, since cerium are useful for producing superalloy. And then for the economic viability, our RAA data from placer deposit is compared to Bayan Obo, China in figure 7. So the REE content of placer deposit in Northwest Belitung is very uneconomical compared to Bayan Obo Karmotantite. Even though compared to the nearest granite rock that is thought to be source of the sediment, the recent sediment REE concentration is lower. This is the consequence of the metamorphic rock as the source of the sediment in our research area that have low RE concentration from the beginning. Finally, we come to the conclusion of this research. So from the discussion before, it could be concluded that REE in our research area is accommodated in zircon minerals, since the REE show a strong positive correlation with zirconium. Consequently, zircon that have high density tend to be deposited first near the source of the sediment. It's reflected by the high concentration of REE in the southeast part of the research area. However, all sediment in the research area have inappropriate RE concentration to be commercially extracted. This condition is related to the source of this sediment, since no identical spider diagram pattern with a viable granite data is observed. The sediment are possibly derived from metamorphic rock that are low in REE. Our study also shown that not all Belitung sediment are enriched with REE. If the exploration are targeted to seek commercial placer deposit in Belitung, they should focus their exploration near the granite. Therefore, the placer deposits could be enriched with REE. So these are our reference for this research. Last, the authors want to acknowledge Pusat Penelitian dan Pengembangan Geologi Kelautan, especially Mr. Maman Surachman. Thank you very much for providing the geochemical data from Belitung Island. The authors I will also want to acknowledge Mr. Bambang Priadi as the advisor from Institut Teknologi Bandung that have already give us supporting advice for this research. I think that's all from me. Thank you very much for your attention.